Hi guys. All right, we made it to the end of Unit 7, Scatter Plots and Data Analysis. So, our main focus is scatter plots, but we are going to be talking about two-way tables as well. So let's go ahead and go over it. First off, let's look at some correlations. All right, when you're looking at a scatter plot, and if it kind of looks like a line, right, going up, that would be a positive linear association. Linear being that it's like a line, positive that when you read it from left to right, it looks like it's going uphill. Then we also have negative linear association. It looks like a line, but then it looks like it's going downhill when read from left to right. Nonlinear or no association would be like they're just literally scattered everywhere. Clusters, these would be examples of two clusters. The space between them could also be called a gap. An outlier would be like if one piece of data just doesn't fit with the rest of it, it's very different from the rest of the data. That's called an outlier. And then a trend line, so it's like if you were to take the data and you were to draw a line as well as you could in between all of the points, what would that look like? Okay, it's also known as a line of best fit. Okay, it's kind of like you're taking an average of all that data. So for this one here, I have a scatter plot set up that it's comparing the tickets sold to the ticket price. And so you can see we have a linear association. It's also a negative linear association, right? It looks like it's going downhill. And what this is showing us is that as the price of the ticket goes up, the tickets sold go down, which kind of tells us like, oh, people don't want to spend more money on these tickets, okay, whatever they might be. All right, so for this one, what I want us to practice is to, one, sometimes you'll have to draw your own or find like your own trend line. To do that, you just want to like put a line kind of as best you can. I'm just using this as a straight edge. But you would just want to put it through as best you can through the data. So in this case, let's just say this is it right here. Okay, it's certainly not perfect, but it gives us an idea of what it should look like. Okay, now with this, there's a few things we could do. We could find the slope of this, which we're going to do, because a lot of times you're going to be asked to write an equation for it in slope-intercept form. Remember, slope-intercept form is y equals mx plus b. For that, we need the slope of the line, and we also need the y-intercept. Well, y-intercept, I was trying to get it right here, which would be at 650, but we'll call it 625, or we'll say 630-ish. And your answers, most of them are going to be in multiple choice form. So just find the one that gets closest to the area that it hits on the y-intercept or y-axis, okay? So next, I'm going to need my slope, okay? Now, one thing I could do is I could just use my y-intercept, and the way I drew it, it actually hit perfectly right there at $17. So I could use those for my rise over my run. I know my slope is going to be negative because it's going downhill. And then for my rise, well, let's see, we went from 630 down to 0. So my rise would be like 630 or negative 630 because we went down. And then we went over 17, right? So we've got my rise over run. Now this is not going to be like absolutely perfect, but what we can do, and let me get my calculator up, with this, in order to put it in my equation, I would take 630 and divide it by 17. That gives me that big long funky number. We'll say it's about 37, negative 37 times x. So this right here, this would be my final answer if it's asking for me to write an equation. Okay, sometimes it might be asking you to interpret the slope, right? It just depends. Okay, in this case, we could say that ticket sales went down $37 for every $1 the ticket price raised. Okay. Got two more problems for us. There's kind of multiple parts in this last one, but that's okay. For this one, a gardener is tracking how many blooms appear on her plant over time. The gardener graphs her data and finds the trend line to be y equals 2.3x. If the plant continues to bloom at this rate, use the equation to predict how many blooms there will be after 25 days. Now that's the whole equation. There's no y-intercept because it's technically 0, right? If there are 0 plants planted, none of them can bloom, right? So that's what that's talking about. But what we can do is we can say, okay, let's see, we've got y equals 2.3x, and then 25 days. Well, x is the number of days, so we've got 2.3 times 25. If I do that on my calculator, 2.3 times 25, that gives me 57.5. But you can't have half of a bloom, right? So you would say about 58 blooms, right? Okay, so that's how you would use the equation. For this last problem, this is a two-way table. This is comparing tech preferences for kids and adults. So we've got we've got people who like tablets, phones, and TV, and then we have the totals in both. So our first task is find the missing values. So let's fill in the rest of the table. Well, for the people who like the tablet, if the total is 50, and we've already used 32 of them, 32 were kids, that means that 18 were adults. Well, going this direction, notice I have everything filled in here. So let's see, we could say 18 plus 7 is 25, plus another 25, well that's 50. And that's good because 50 plus 50 is 100. So that also tells me that I could do this one here too. 50 plus 30 is 80. And if I need my total to be 100, that means this one has to be 20. Oops, 20, not 28. I don't know where that 8 came from. And then that's also good because 13 plus 7 is 20. So then my last one is just this one here. Well, if my total is 30 and 25 adults prefer the phone, that means 5 kids prefer the phone. And then going this direction as well, we could test it. 32 plus 5 plus 13 does equal 50. So we're good to go. So we finished that one. With the next one, it says, what percentage of adults prefer a tablet? Or this could also be referred to as relative frequency. Okay, so if we're looking at adults, right, we know that there are 50 adults total. We need that information for our denominator because it's a certain number of adults out of 50. But let's see, adults that prefer a tablet. Well, that was 18. Okay, so, but it says what percentage? Remember, percents are out of 100. So one thing I noticed right away is that I could multiply both of those by 2, and that makes my denominator out of 100. And then 18 times 2 is 36, so that would give me 36%. You also could have divided 18 by 50. That would give you the decimal of 0.36. And then multiply that by 100, again getting 36%. And then our final question, how many people prefer TV? Well, here's TV, and we just want to know how many people prefer it. Well, and that would have been 20. So that's your final answer. Okay, so filling in the table and then reading the information in different ways. All right, I hope this helps you review for your test. And as always, if you need extra support, you just let me know. And otherwise, have a great day.